Hello, this is Travis Bliss, and my presentation is over the effectiveness of English language learner co-teachers. The problem is that the school district as a whole is experiencing lower math scores every year over the last 5 years, and the purpose of the analysis is to improve those test scores. We've drilled down to find out that the lowest test scores, standardized test scores in mathematics, come from the demographic known as the English language learners, but for two reasons. Number one is that population's increased the most over the last 5 years. It's now considered a majority, so it's what's called a minority majority of the school district population, but their mathematic testing scores are at the bottom. So obviously, the more students taking the test that score lower, the more rapidly the overall average drops. So we've been tasked with stopping that and reversing that. Okay, during the literature review process, we analyzed how to bridge the gap between those at the top and those at the bottom. We found out during the literature review process that the academic language, or I found out, academic language in part was one of the biggest contributors to the difficulty that they EL students were having in understanding the math. The everyday language they seem to be able to adapt to fairly quickly. How to find a classroom, where's the counselor, what time to be present for school, what time the school is out, what is my schedule look like, those type of things. Where's the lunchroom, how to order. Those were, the learning curve on that was a lot less steep, if you will, than academic language. Academic language, because it's just constricted to simply being there at the school, essentially, that is the most difficult time they have with it, because during the literature review process, after reading all of the different analysis on this issue across the United States, they found that a large majority of the EL students, they practice academic language at school during the 8-hour window, Monday through Friday. But then when they're at home or they're back in the community, they find ways to interact with people that speak the same language they speak, whether it be Korean, Vietnamese, Spanish. So they come into math class, they hear about the word coefficient or supplement or angle, even something like angle or triangle or whatever. And then when they go home for the weekend or whatever, they ask to watch TV. They talk about lunch, dinner, breakfast, a movie, the mall, a job, in Spanish, Vietnamese, Korean, whatever. And so there's that break between academic language and everyday language. The analysis that I did specifically tried to drill down on what the benefit of having a co-teacher in the room is, because that's money. Number one, the school has to factor it into their budget. Is it worth actually expending this money on or not? Number one. Or number two, is it just simply a wash? Or is it, number two, maybe it's actually not helping the school at all? Maybe it's derogatory. Maybe it's bringing them down. And then so we looked at trends over the last 5 years, what's going on with the test scores and what's going on with the amount of co-teachers that are in the rooms. And then lastly, obviously, the literature review touched on scholarships, because the people that need the money the most to go to college are the ones who know the least about how to get that money to go to college. So if we're really trying to help these students not only graduate high school, but do something above and beyond after they get out of high school, not only do we have to figure out a way to help them pass and be successful in high school, but we got to show them that there's more to academia after their high school career is over. The study that I did, or that I put together, that I developed, was comparative quantitative analysis. The reason why I want to do this is because we simply just want to take a pre-test, like standardized math test, because that's what the problem is standardized test scores being low. Pre-test everybody, go through the semester with this group has a co-teacher available and present in the class over 90% of the time. This group does not have a co-teacher available, and goes through the semester. Both teachers learn from the same lead mathematics teacher. So the only variable would be that one class has a co-teacher and one doesn't. And so at the end, we're going to compare the scores on the post-test for the net differential between the original test and the final test. So in other words, if a student with a co-teacher raises their score from a 50 to 100, they went up 50 points. Okay, and then the teacher on the other side of the demographic goes up from a 30 to an 80. That's an increase of 50 points. They both increased the same amount. So we're not looking at a raw overall score because one student may start higher than the other, and then we're not comparing them accurately. And so, which leads me to the design, I guess. Pearson product moment correlation coefficients. And so essentially what that is we tie a coefficient. Correlation means is we correlate the scores to the student and whether that's a net gain or loss, and then we quantify that with a number. So student A, net gain 3 in this category. Student B, net gain 2 in this category. We compare all the students in one category, say with a co-teacher. And then all those scores are added up, net, divided by the total. So what's the average net gain per student? And so that'll be, and then that number will be tied to the overall number of students. That'll be the coefficient. Then over here on the other side, we take the group with the I guess if I have one without a co-teacher, one with, and the one with a co-teacher is going to have the same thing. Because odds are you're not going to have the same, even though we start out maybe even with the same number of students in each category, you have add drops. Say this group over here adds 3 students, and this group over here, 3 students drop out. Well, that's a 6-student swing. That's a 6-student gap, which could affect our numbers if we don't tie it through with this Pearson product moment correlation coefficient. So because we tie the coefficient together to each group, then it won't. Those kids that drop or add shouldn't affect the overall final number nearly as much. It's kind of like if you were to say pound for pound or per capita. The average salary in Oklahoma per capita is $50,000, whatever. Well, if 10 people move out of Oklahoma and 10 people move in, and the 10 people that moved out were making $100,000, the 10 people that move in start making $20,000, because we're running the numbers on a per capita basis. Those two subsets of 10 should not affect the overall number enough statistically to skew our whole results and throw out the whole test. So that's essentially what we're trying to get to with that. Okay, so in conclusion, midway through the analysis, interestingly enough, as I keep reading into this, trying to figure out what we can do, is the student. One of the things that has been picked up on is the students that have the bilingual co-teacher actually are still struggling with mathematics when it comes to the test part of it, because the tests are written in English, and as of today, the test will not be written. Standardized tests will not be written. The State Department of Education won't allow the test to be written in a language other than English. And those kids, the students that have a bilingual co-teacher, they're relying so heavily on her or him to interpret the questions that, they're getting better at the actual math. They're knowing the math. But when it comes to actually reading the questions, they're having more difficulty when the legit, they get the homework. The co-teacher reads it in English in her head and turns around and translates it in Spanish to the student. The student goes, okay, solves the problem and turns in the right answers on homework. Teacher's thinking, this is great. They're getting fantastic. This co-teacher's making a big difference. And then the test comes out. It's in English. Co-teacher's not allowed to interpret it. Teacher can't help or assist or any of that. Tests are coming in. Test scores are down. Homework grades are going up. Meanwhile, the classes without a co-teacher are remaining at a fairly low but still constant rate, because they're somehow finding a way to get through the English verbiage because they have to on the homework, so therefore they have to on the test. Their math capabilities per se may not be any better, but they're tasting about the same, interestingly enough. So we haven't got to the final numbers yet to turn in, but I would suspect, just to throw out a hypothesis here, if I could change it mid-research project, because going into the project, I believe that the bilingual co-teachers would make a significant difference on test scores. Now looking at it, there's a good chance that they end up right. There's no statistical difference. There's a good chance of that happening, just because, like I said, the bilingual co-teachers, the unintended consequences are that they're in effect providing a crutch for the students to lean on to not have to learn the English side of things. So therefore, when they receive the test that's written in English, they just go, well, I don't know. If somebody could just tell me what this means, I could probably solve it mathematically. Anyway, hope you find this as interesting as I did, and hopefully helpful as we go forward, trying to make the education process better for all students, and especially those that struggle the most with the content. All right, thanks.